Hello, I'm Macy.
And I'm Mariana.
Today we're going to be covering this wonderful thing called impulse. But whatever could impulse be?
Luckily, we have an acronym for you.
I is for impulse.
M is for momentum. Can't have impulse without momentum.
And then P is the symbol for momentum.
You are going to learn today.
L, that's not what you're gonna take.
S, so good.
E, everything is going to be covered.
To understand what impulse is, it's important to first understand the concept of momentum.
Momentum can be described as mass with motion. If you are moving, then you have momentum. The equation for momentum is P equals mv, where m is mass and v is the velocity of the mass.
It is important to notice that velocity is a vector, therefore momentum is a vector too.
Now for a quick momentum demonstration from Now that we're basically experts on momentum, we'll learn how momentum relates to the concept of impulse.
Impulse can be described as the change in momentum, or J equals delta P.
Impulse is a term that quantifies the overall effect of a force acting over time. It is often given in the symbol J, and it is expressed in Newton seconds.
For a constant force F, J equals F times delta T, as we saw earlier. This is exactly equivalent to the change in momentum, delta P.
We can actually derive this equation from Newton's second law, F equals ma, where we replace acceleration with delta v over delta t, and then we multiply delta t by both sides, putting the delta t on the side of the force, and leaving delta v on the side with mass, giving our impulse equation F times delta t equals m times delta v, which is the same as the change in momentum.
This equivalence is known as the impulse-momentum theorem. Because of the impulse-momentum theorem, we can make a direct connection between how a force acts on an object over time and the motion of this object.
This probably makes no sense right now. It is a difficult concept to understand. Luckily for all of us, we are here to make the learning process easier.
We will demonstrate the concept of impulse through an experiment called impulse. Okay, so today for our experiment, we're going to be doing the impulse thing like we talked about before. So we're going to do the egg drop. We're going to start off this experiment by just testing like a single egg with absolutely no protection off of right here, which is 10 feet tall. So we're going to get that started. Okay, so I'm going to be timing this too so we can really discover what the force really is. Okay, so plane A, here we go, 3, 2.
And as you can see, our egg ended up cracking because it had no padding when going down.
Okay, so now we've put the egg in a container filled with water, and we'll see if the water is enough to increase the time of impact in order to decrease the force that is exerted on the egg and thus not allow the egg to break. So we'll see how it goes.
This is what our egg looked like inside the water.
Okay, so now I'm going to drop it. And the time was 1.1 seconds.
And as you can see, the water was not enough to protect the egg. As you can see, the yolk pouring out of the egg.
Okay, so now we're going to try a parachute, and we can already start to see a possible error in our part because it is windy today, so it might not work to its full potential. But we're really hoping this will increase the time of impact, so the force will decrease. So then the egg is not harmed, so we have my beautiful makeshift parachute here to try that out.
Okay, so here we go, and I'm tying this also. 3, 2.
And it seems that the parachute failed as well, and the egg cracked.
Okay, so now we have this box that has been padded with some bubble wrap, and we've wrapped the egg itself in more bubble wrap. So we're gonna see if this is enough to increase the time of impact and decrease the force exerted on the egg, and see if it will finally not break. So let's go find out.
Okay, so now I'm going to drop the box close, and we'll see. Okay, ready?
See if it cracked or not. The huge reveal. Would you like to explain why this works, Mariana?
Well, the bubble wrap was enough padding, in a sense, to increase the time of impact. So the force that was exerted on the egg was actually decreased, causing it not to break, meaning that this padded box saved the egg.
And how does this relate to impulse?
Well, as we saw in the impulse equation, since momentum is technically set in this scenario, the only variables that would change is the time of impact and the force exerted on the egg. And as I've said before, the time increased, so therefore the force decreased, causing the egg not to crack.
Wonderful. We decided to do the ever so famous peanut butter egg drop. So the egg is covered up, but it is indeed in there, and we're going to see how this this affects the time of impact, to see how that will relate to impulse and if it will really crack the egg. So let's give this a try. 3, 2, 1.
Okay, let's see what happened.
Okay. The top here is shattered. I don't know what that means. So the egg is covered up. So far it looks all good. Let's see if I can take this out. Indeed, it is covered in peanut butter, but it does seem to be in perfect condition. So obviously all the impact was absorbed into the peanut butter, and that increased the time, so the impact to the exact egg is not that hurt. So the impulse is here.
Yeah. Go.
Yeah, yeet!
The egg is intact. Oh my god.
That is, Mariana.
Why?
There's all that grass there, and it decreased the impact, so it wasn't that strong of a force.
To show impulse in a more real-life way, here's Macy, who's gonna give you a few examples.
Hello, Mariana. Thank you for that introduction. So some examples would be someone punching you. So you have to move to the direction of the punch. So yeah. Additionally, climbers use nylon rope, and so in case they fall, the rope will extend the most they can. So that increases the time and decreasing the force, so it doesn't hurt the climber. So those are some examples. Thanks.
So today we learned about impulse. Impulse is all around us, and it's an important concept to understand.
We hope that you are now solid on what impulse is, and you can apply it to your real life situation. Thank you. Like and subscribe.